Okay, so this is part 2 of the Team Losi 22.4 build series. I decided to get through 2 parts bags here instead of just one before making the next video because the B parts bag was literally just building the rear diff and mounting it and putting this cover on, and then the C parts bag is building the front diff and the steering rack and then mounting all that and putting the front cover on. So I figured I'd just make one video for all of it. Before I get to any part of that, I actually just want to point out briefly, going back to the slipper clutch build, excuse me, I forgot to mention that the spur gear here, as you slide it onto the lay shaft, it's actually a pretty tight fit. The diameter of the opening on the inside of the spur gear and the diameter of the lay shaft are very close, so you really got to sort of jam it onto the lay shaft. Now, what that effectively means is the friction that you have between the spur gear and the lay shaft is going to contribute to the total friction of your slipper clutch assembly. In an ideal system, you would have zero friction between the spur gear and the lay shaft, and the only things that are providing friction are your slipper pads. But here that's not the case. The spur gear is also providing some friction against the lay shaft. So don't be surprised if that wears in and you find that, that finally starts to loosen up, and then you have to tighten your slipper clutch down a little bit to compensate for that. If you want to, I guess you can, take a Dremel or something and bore out the center hole here, but I didn't do that. I don't want to really fiddle with that, but you probably could. Again, I pointed out in the previous video that Team Losi does have a video on how to set the slipper clutch. But despite that, I do have to say that I would like it if they had something in the manual to teach newcomers to building kits on how to set a slipper. It's nice to have it all in one manual than having to go online and learn how to set it. So I'm not too crazy about that. They could at least give you, some kind of measurement for like where the nut should be on the threaded part of the lay shaft, or how long the spring should be, or how much it should be compressed, so you can measure it out and say, okay, that's a standard setting to start with, but they don't have that in the manual. All right, now going forward to the diff, I have the same complaint. For both the front and rear diffs, they do not tell you how much to tighten it down or how much to back it off a full lock for a standard setting. If you look at Team Associated manual, they almost always do that. Here they don't do that. But otherwise, putting that aside, the build went together just fine. I have no real complaints. The diff rings are notched, which means they lock against the diff outdrive, and so there's no slippage between the diff ring and the diff outdrive, which is good. That means the only diff action that you get is between the diff rings and the diff balls, which is great. Now I have heard that the rear differential on the 22.4 tends to wear out quickly on high grip surfaces, and that the slipper clutch alone is not enough to compensate for that. So what that makes me think is maybe the rear diff is slipping. And if it's slipping and the diff rings are not part of that, then really the diff rings are slipping against the diff balls. And in an associated diff or any other type of diff that doesn't have this notch, the diff rings would also be able to slip against the diff outdrives. Now, you wouldn't really want that for a proper diff, but at the same time, it does dissipate some energy rather than sending it through the diff balls and wearing out the diff balls. So this should be a better approach to building a differential 99% of the time, but there may actually be instances where you would prefer the diff ring to slip a little bit against the diff outdrive in the event that your slipper clutch alone is not quite good enough to dissipate all of the energy that's being coupled through the drivetrain on a high grip surface. So maybe this notch diff ring has something to do with the rear diffs wearing out quickly. I don't know. I race on medium to medium high grip, so I don't think it'll be a problem for me, but I just wanted to point that out. Also, the actual diff rings themselves appear to be pre-sanded, which is a very nice thing to have. So normally when you get a diff ring, it looks very polished, and the general I guess, rule of thumb, or what you might see professionals do, is to actually sand down the surface of those diff rings to make sure that the surface is completely flat, and you get more consistent diff action. These appear to come pre-sanded, which is very nice. I normally don't even sand them down myself. I just wear them in over time, and they run just fine. But that's a nice little touch. What I also appreciate is that they give you a ton of grease. I mean, these are very, very big tubes compared to the tubes you might get from Team Associated, which are maybe that large. So this gives you more than enough grease. This is after, fully building both diffs, plenty of black grease left, plenty of white grease left as well. So this will last you several diff rebuilds, which is really nice. I really like that they did that. Let's see, going forward, so we got the rear diff, mounted it, right, put the cover on, no big deal. And then to the steering rack and the front diff. So front diff is mounted and everything. The steering rack itself is fully locked, which means that there's no servo saver in this steering rack, which is fine. That seems to be a modern trend in modern chassis, and it makes sense because a lot of the high-performance servos out there have metal gears. It's not like 20 years ago where they were mostly plastic gears and you needed servo savers to preserve those plastic gears. The metal gears in modern servos can really handle the beating that you give them. So you don't need to dissipate any energy in your steering rack through a little servo saver assembly. So that's good. You get more direct steering response. The problem is this steering rack is a plastic steering rack. So if you hit something really hard, it is possible that the steering rack can break. In other systems like, maybe a B44 or a B4 or something, you can get solid aluminum steering racks, which are much more durable. So that, if you decide to forego the servo saver, you at least have a metal steering rack that will not snap. So I'm a little concerned about this steering rack possibly snapping if I hit something hard enough, but we'll have to see. I have heard that the servo horn that's supplied with the kit, the servo mounts here, the servo horn goes somewhere over here. That's also a plastic unit, which is normally fine if you have a servo saver, but that this horn tends to snap first. So I actually purchased the aluminum servo horn that I'll be mounting when I put the electronics in. But that means if I have metal gear servo and aluminum servo horn, something up here is going to give. It's gonna break. So we'll see how that goes over time. Let's see. So the front diff's done. Diffs are all installed. I would say that when I set the front diff, so if I go back to the diffs for a moment, for the rear diff, when I set it, normally I'm used to going full lock and then backing off 1/8 of a turn. That's how I set up my associated diffs for a standard or a baseline setup. When I did that to the rear diff, it felt too tight, so I backed off another 1/8 of a turn for a total 1/4 of a turn off of full lock, and it feels okay. For the front diff, I tried doing the exact same thing, but I think I might have flat spotted the diff balls. It's not too bad, but we'll see how that goes. I've dealt with worse, but I'm guessing the diff balls are made of steel, because if they were tungsten carbide, you would not have this problem. But I find it difficult to imagine how you can expect someone to assemble a diff and then have to set it with a nominal setup that's not even provided here, which means you have to go off of experience, which means going full lock and then backing off by some amount. But when you don't know exactly where full lock is and you have softer steel diff balls, you may end up flat spotting them if you're not careful, like I was here with the front diff. I don't expect it to be a huge problem. Again, I've dealt with worse, but just something to point out: be really careful when you tighten down these diffs. The diff springs, I'm guessing, are maybe a little bit more tense than something like you would get in an associated diff. So that would mean when you go a smaller amount off of full lock, it's still pretty tight. So you may have to back off a little more than that. With all of the drivetrain effectively assembled, so the front diff, center lay shaft, the jack shaft, and the rear diff. With the stock belt tension settings, the drivetrain is pretty tight. It actually feels a lot like my SC10 4x4 in terms of the tightness. So this will need some time to break in. Do not be surprised if your motor temperatures are pretty high for the first few runs. So I'd be a little concerned about that. Maybe you might start off by gearing down a little bit just to help the drivetrain break in without pulling too much current from the motor. And then as it wears in, then you can gear up a little bit. But that's sort of where we are right now. So far, the build is okay. I'm moderately satisfied with it. I give it maybe a 7 out of 10. It's okay, but it's a very interesting kit anyway. And I'll continue with the build and make a video either after the D section or maybe partly into the E section, depending on how far this takes me. And we'll go from there. So thanks for watching.